Okay, I'm ready. I'm going to tie up the spring on one side in my chair. Yeah, kind of. And I'm going to hold the other side. So I use this to, I'm going to use this to talk about waves. Okay? Wave is a physical concept that is used to describe the transmission of energy without a net transmission of mass. That's the whole idea. For instance, if I shake, you see, it comes back, yeah. But the idea is that my shaking my hand, I don't know about the angle, but yeah. You see, it goes back, but the idea is that there is a transmission of energy from one point to the other. So that's the idea of a mechanical of a wave in general, but in this case, it's a mechanical wave because it needs a material to transmit. There are other types of waves. There are electromagnetic waves that they can travel in the vacuum, okay, in the empty space, because there is a electric and magnetic fields that induce one to the other, so it can transmit in the vacuum. And they are also recently predicted by Einstein and recently observed the gravitatory waves. Okay, when they were measured when two black holes collapsed some years ago was measured. Yeah, one day I'll tell you about it. Well, I can tell you now that I met one of the discoverers. He made the optical part, and he got a Nobel Prize for it. He came. Well, I didn't meet him in person, but okay. Let's finish and I'll tell you. So there are longitudinal waves where the propagation goes in the same direction of the perturbation. I'm tired. And this is longitudinal. Transversal waves, see the propagation is vertical. Yeah, I don't want this going back. Okay, let me get it. Let me free the spring, because since I have the return, have the echo or the reflection of the wave, it's kind of confusing. Okay, so this is the longitudinal. Okay, longitudinal, transversal. Yeah, the transversal, you're going to see better in this way. Okay, and now I'm going to do, and I have to tie it up again. I don't know what I left. So now I'm going to do what I'm going to do the stationary waves when there's an interference of one wave and the echo in the reflection, and then if you meet a kind of requirement, there's a superposition in a, yeah, let me see if you can. So there are points of no vibration. You see the structure? This point is not vibrating, it's almost no moving, no movement. Can do it faster. But yeah, you see, this is a stationary wave, you see the shape, okay? There are points that almost not moving, Yeah, so the stationary waves are very important. They're very important. Very important in musical instruments. Okay, these are resonance in the, for instance, a guitar, okay, or a drum in the box. So all the boxes that are used in the instruments are for the resonance. All the tubes as well, the flute, the horn, and then the box for the violin, and the cylinder for the drums. So they are all resonant cavities. Okay. Yeah. So the stationary waves are created, and then what am I talking about? Resonance. I'm talking about stationary waves. Sorry, forgive me. I can kind of confuse it. So the idea is that stationary waves are a wave that is interferes with the echo. For instance, with stationary waves. Yeah, the string in the guitars. Yes, that will be, and it will be under stationary wave. And then the resonance and other things what we saw yesterday in the previous videos with the there are different things. Sorry, but they kind of go together. That's why by the proximity I kind of mix them up. So you have the stationary wave, which is the string in a violin, for instance, and then you hear it because there's a resonance in the box. Yeah, they're kind of close, but they're not the same. Let me see if there's something else in the box. Yeah, I think there's another spring. The idea is the same. This one could even work better. I never tried. I haven't tried. Okay, let me see. Yeah, could be better. So this is the longitudinal wave. Good. Transversal wave. Good. Because it's perpendicular. And then let me see if I can do this stationary wave. No, you have to do this stationary wave. You have to find the frequency for the modes. Yes. And in the flutes, you have the stationary waves. I don't quite know, right? Because I didn't study much mechanics one year, but I didn't study acoustics, and I've never been really interested. Physics is so vast. There's so many things to study. Okay, let's see if I can make like a Frankenstein with the two springs, and show you a better view of this stationary wave with the other. Okay. Wow. Longitudinal. Yeah. Transversal wave. And then